Let us look at the second types of collision. Now we have done head on head collision, or head to head collision, or head to end collision. So which is comprised of elastic, inelastic, no. And the end to end collision is a collision that is occur on a straight line between two bodies. So the second type of collision is called oblique collision. Is a collision in two direction. Yes. Where the previous one is collision in one direction. So the oblique collision is a collision of a two or more body in two direction. And the colliding body, they will move in different in different paths. And this kind of collision is very common in a collision of the snooker ball. Let us look at it now. Oblique collision. So, okay, let's say this is a, what can I use here? Use the marker. We have a body here. Yeah. No, let me use this blue blue marker. Mhm. Mm-mm. Assume this is a what? A ball what? A. This is what? Ball B. So when this ball A is what? Is coming along what? This direction. Like this. When the ball A gets A, it hits what? This is also what? A. When this ball A hits what? B. So the B will move along what? This direction. And let me rub this topic here. To rub what? B. So when the B now get to this side, this will be the what? The what? The B. This is what? The ball B. And when this ball A collide or hit the what? The B. This ball B is B at what? At stationary. B is at what? At rest. The ball B is at rest. This one is what? Is moving. So you can now observe that what? The A will now move along this direction. So the ball A will move along what? This direction. When ball A move another direction, it will now come to the what? Its own final what? Direction for B. So let me say this. This is also what? A. This is also what? A. And this is what? Ball what? A. A collision. Let me change the marker for red. Yes. So this red can also have it in this form. And this is what? Red. This is what? Red. And what we now do now is what? When this body move like this, let me draw a what? This parallel line will continue like what? Like this. You will now observe that we have angle here, which is angle what? Theta, call it theta 1, where they incline on. And the angle we have here, we call it what? Theta what? 2, where what? The one incline on. And at this particular place now, you can have mass what? A with speed of what? This one is A, or we call it what? Mass 1 UA. And this B is at what? At rest. We know that what for the at rest, U equal to the what? 0. So the mass what? B and UB is this. So after what? Collision here, the mass B with V what? B, and here we now have what? Mass what? Mass A, final velocity what? A. This kind of collision is very common in what? In snooker ball. Assume this is a white ball that you use to what? To hit or to strike the red ball. If you hit the red ball go like this, the white ball come like this. And this is the angle, the form with what? The initial horizontal what? Line. So in this case now, we now apply what? Law of what? From conservation. Law of what? Linear what? Momentum. We said that the total momentum of a body before collision is equal to what? Total momentum of the body after what? Collision. Abi? But don't forget the body is what is at rest. Everything will be what will be 0. We have 0 plus what? MA, UA should give you what? MA, VA plus what? MB, VB. You have what? MA, UA equal to the what? MA, VA plus MB, VB. We can call this one what? Equation what? Equation 1. And the next thing we need to do is what? This equation 1, we need to write it in a vertical component as well as what? Horizontal what? Component. That is, if we resolve this equation, this sketch, if we resolve it, if what we resolve this thing both in vertical and horizontal what component. For this one, I'm very sure it will be what horizontal component will be what M B V cos theta 1. For this one, what are we going to have? We have M what A V A cos what theta 1. We have done it in a resolution of what? Of vectors. So if you missed the class, go and check my previous video, vectors analysis. So to resolve this in a horizontal plane, for this one, it be what? M1 V1 cos 1. So it be what? M1 V1 cos what? Cos theta 1. Sorry, the theta for this will be what? Theta 2. And again, if you want to solve for what? For vertical component 2, for the vertical component here, what are we going to have? We will have what? MB VB sin what? Sin theta 1. So this side will be what? MA VA sin theta what? 2. We have it under resolution of what? Of vector. So you will now substitute for it here by saying for horizontal component, so you can now have what? MA UA should be equal for this horizontal component now. This one, you can have what? MA VA cos theta what? 1 plus M what? B BB cos theta 2. See, this is the what? Formula equation 2 for what? Horizontal what? Component. These two after collision. Before you still remain. Just take this one to what? Put cos here. Put cos here. So you can now say what? For vertical what? Component MA UA equal to what? MA VA sin sheet. A is sin theta 2. Sin theta 2 is theta 1 plus MB B VB cos theta what? 2. Wait, cos theta 1. Theta for MB is 1. So this is also what? Formula for what? Vertical component. Yes. You can now see something here. If you observe that what? This local ball, they are ball of the same size and the same weight, mass. Snooker ball have the same size and what? The same mass. So you can now say what? If mass MA is equal to the what? MB equal to the what? M. That is, they are of the same what? Same size and weight and what? Mass. When the mass are equal, what are we going to have? Change this one what? M. Here we have VA. Here, take this one to M. Here we have VA sine what? Theta 2 plus M VB. And this M is common. We have M what? UA M VA sine theta 2 plus VB sine A cos theta what? 1. So this cancel each other. UA equal to the what? VA sine theta 2 plus VB cos theta what? 1. So we can have this, the vertical can reduce to what? To this. Call it what? This one I reduce to what? This equation what? Equation 4. And this for horizontal can also, this one can also reduce to what? To UA VA cos theta 2 plus VB cos theta 1. Equation 5. But if collision is what? Is elastic. If what? Collision is what? Elastic. Which is elastic what? Collision. The kinetic energy is what? Conserved. Which is constant. We can have what? KE before equal to the what? KE after. What is KE before? Half of what? MA UA square equal to the what? Half of what? MA VA square plus half of what? MB VB what? Square. So from this expression now, if the mass are what? Are the same, cancel each other, you now later have what? Let me say, you now have what? You now have what? You will have if the mass are what? Are the same. Like here, you will now lead to U square, U A square, VA plus what? VB what? Square. Equation what? 6. So no matter how they choose the question, so you can use what from equation 1 to equation 6 to solve for any oblique what? Collision. Let us solve one question on it. Yeah, solution. Let's solve this question under oblique collision. Yes. Yeah. A ball moving at the speed of 5 meters per second strike a stationary ball of the same mass. Good. Stationary ball of what? Of the same mass. That is, we are given what? Speed U what? UA as 5 what? Meter per second, and the mass MA equal to the what? MB equal to the what? M. Mass are equal. I said it before. For the snooker ball, the mass are the same. After collision, the original ball of the same mass, after collision, the original ball of the same but move off with velocity of 30 degree. Yes. So that is what? Theta what? 1 there is what? Original ball. Equally what? Theta what? Theta 2. Uh, Note that the angle for this original ball is theta what? Theta 2. The angle for original ball is what? Is theta 2. So call it what? Theta what? Theta 2, or the first what? Theta. Abi, how am I going to put it? Let me call this one what? U1. Let me call it what? U1. This one will be what? U what? M1, M2. And the theta for this speed of original ball, call it what? Theta 1. But here, I call it what? Theta 2. Don't forget to, my original ball is blue here, Abi. Or, to avoid confusion, let me still go back my words. Call it what? 2. Let me call it 2. Let me maintain my standard here for A again. No confusion, A. Here we have B. So, original motion. If we assume elastic collision and collision is elastic and disregard the frictional force, good. Find the magnitude of direction, which is what? Theta 2. And what? Velocity, direction of velocity of the target ball after collision, which is what? Our V. So you cannot say what? For what? Horizontal component. We have done it here before. So what is that component formula? We have MA UA equal to the what? MA VA cos theta 2 plus MA MB VB cos theta what? 1. Because theta of V B here is what? Is 1. Let's substitute for it. Yeah. Note that the mass are the same. If mass are the same, take the mass out. And to be in this form, you now have what? U what? UA should be VA cos theta what? 2 plus what? VB cos what? Theta what? 1. UA will be what? What is? Sorry? Our UA here is what? 5. I'm having 5. What is VA? Unknown. Cos angle of that one is cos what? Cos 30 plus what? VB or what? Unknown. Cos what? Theta what? Theta 1. You can call it what? Equation what? Equation 1. The second one, let us look at what? For vertical component. For vertical what? Component. What do we have? Vertical component directly is this. Is vertical component. We have what? M what? MA UA MA VA sin theta 2 plus what? MB VB cos theta what? 1. Yes. Mm-mm. Sorry, oh, this is a big mistake. Here is sine theta what? 1. Where am I see it? For vertical component. Vertical, horizontal. Vertical sine. Huh? I'm very sorry. Sine theta 1. But everything vertical is sine. Sine theta 1. Here we have sine what? Theta 1. God. Huh? Sine what? So when the mass is the same, you will now have what? VA. And again, note that this is vertical. After, do we have anything for vertical before collision? No. So for this initial for vertical before collision, everything we have here is what? 0. So take M out here. Take what? The M what? Out. Let me do it first like this. Let me take the what? The M out first. You have VA, VA, VA sine. My theta there is what? Is 30 plus VB sine theta what? 1. Mhm. So here it be what? 0. There's nothing in the vertical component. We have what? VA sine 30 plus VB sine theta 1. So this one you call it what? Equation what? Equation 2. You can say that there is a little mistake from the question. It said after collision, the original ball move off with a velocity of 3 meters per second at 30 degrees. That is what? The velocity of what? VA. So sorry, the VA is what? Is 3 what? Meter per second. So the VB is what? Is unknown. Because it's what? Is an elastic collision. They will not stick together after collision. So they separate. So here now, so the VA here, it should be 3 what? 3. So let me rub this, my vertical here. So if this VA is what? Is 3, we will now have what? 5 should be equal to 3 multiplied by, cos 30 is 0.8660 plus FB cos what? Theta. So help me to put calculator for 0.5 times 0.3 times 0.860. You now have what? 2.60 plus VB cos theta what? 1. Cos multiply. You now have what? VB equal to VB cos what? Or let me say here 5 minus 2.60 equal to the what? VB cos theta 1. You now have what? 2.40 VB cos theta what? 1. So instead of using this one as equation 1, this will be what? Equation what? Equation 1. So yeah, the second one for what? For vertical component. So what is the vertical component formula? We have this. will be UA equal to the what? VA sine theta 2 plus VB sine theta what? 1. U initial velocity is 5. This one is 3 sine what? Sine 30 plus what? VB sine what? Theta. You now have what? 5 into the what? Then here we have 1.5 plus VB sine theta. So you now have what? VB sine, subtract this from this. We have 3.5 VB sine theta what? 1. Equation what? Equation 2. So to solve it easier now, we will now, we have what? Equation 1, equation 2. If you remember from my previous math class, under trigonometry, what do we have? We have, this is what? Cos, this is sine. But what can give us what? If you divide this by this equation 2, divide equation by equation 1, you get tan. Abi? That's what? Divide equation 2 by equation what? 1. What do we have here? Equation 2 is 3.5 VB sine what? Sine theta. Equation 1 is what? 2.4 over what? VB cos what? Cos theta 1. So VB cancel VB. We now have what? 2.4 divided by this. You have 0.625 equal to the what? Sine over cos. We have done it in trig in mathematics. Sine over cos is equal to the what? Tan 1. So you now have what? Our tan arc of tan 0.625. So you now have what? Angle. If you press your calculator, it will give you what? 30 what? 32 degrees C. So that will be the what? The second angle here will be what? 30 what? 32 degrees C. Where the first angle is what? Is 30. So the last one is what? We are asked to find the what? The magnitude of velocity. Know the what? The direction, which is theta. It remains what? Velocity. So you can now say what? To know the velocity now, you can say what? Let's square. Let's by squaring equation 1 and equation 2. If you square what? Equation 1 and square equation 2, then you will add the two together. So by what? Squaring equation what? 1 and equation 2, then add what? Add them what? Together. What we do now? This is equation 1. It will be what? 2.4 square plus 3.5 square is equal to what? You have V. What is VB? VB square. No, let me say what? VA square sine square theta 2 plus VB square sine cos square theta 1. Hmm. Yes. If you're doing it in this form now, so you will now have what? 2.4 square plus 3.5 square. This will be what? 5.76. This one will give us what? 12.25. Then we have v what? Square sine square theta 2 plus cos square theta 1. Everything here is equal to 1. So if we add this one together, we have what? 17.81 equal to the what? V square. And the v will be square root of 17.8 what? 81. It will now 0.81. Where's your calculator? What do we have? Where's calculator? The final answer you get here is will be what? Meter per what? Seconds. That will be the final what? Answer.